All right, so welcome to Math 409 problem solving. What I wanted you today is finish a little bit on the DoublePlusOne problem, and then go from that to talk about divisibility rules, which I've talked to some of you about. How do you determine if an integer is divisible by certain numbers? And so what I did is I wrote a Excel sheet, and I just pasted a little bit of the results here, just to show you how easy it is if you want to just calculate up to 100 for a given n. What is the probability that you have no runs of length 5, or conversely, the probability that you do have at least one run of 5. And so Q1 is the probability that you have a run of length 5 or more blacks. And we can see with 100, it's just 81%. So everyone should have enough basic Excel or Google Sheets knowledge so that you can make something like this really quickly. If you don't, please let me know. This is a skill you need to have. By now, I would assume everybody has done this through school or whatnot, but basically, you just set in the first 5 values to be 1, and I'm multiplying everything by 100, and then this is just 1/2 of this minus 1/4 of this minus 1/8, and so on and so on, and then you just fill down for the formula, and the Q's is just 100 minus that. All right, the next thing I wanted to do on this problem before we move to divisibility rules is to talk about trying to bound the value. So if you're not able to see the recurrence relation, can you at least come up with some rough idea of what the probability is? And so let's say we want to look at n equals 100. Okay. And so what we're going to do is we're going to look at blocks of different sizes. And maybe we'll do blocks of length 5, and we'll have 20 of them, all the way down to blocks of length 10, and we would have 10 of them. And what we want to do is we want to try to calculate a upper bound, lower bound for some of these problems. So let's say we want to try to find a lower bound or an upper bound for the probability we don't have 5 consecutive blacks. Which do you think is better, a lower bound or an upper bound? So we're trying to decide, do we want to go to Vegas? Do we want an upper bound for the probability we go bankrupt, or do we want a lower bound for the probability? We want a lower bound. Okay, the upper bound is at most 100%. Thank you. Yeah. I actually do have a paper where I prove the probability that something happens is at most, I think, 250%, and have to do a little bit more work to get it to something useful. It's the lower bound we want. If we can show that the lower bound is 1/10000000th of a percent, okay, well, unless I know that this is somewhat close to the truth, I'm not that happy. But if I show that the lower bound is 60%, okay, now I'm concerned. Even if it's not the truth, it's a large enough lower bound that I know something is going on. So let's look at blocks of length 5. We have blocks of length 5. Let's say we want to calculate the probability we do not have 5 consecutive. Okay, so we want a upper bound for do not have 5 consecutive black gives a lower bound. So we do not have for we do have. And because it's the probability we have 5 consecutive black is equal to 1 minus the probability do not have 5 consecutive black. And so if we get a lower bound for the, so if we get an upper bound for the probability we do not have 5 consecutive blacks, that's going to give us a lower bound for the probability we do. So let's try to calculate an upper bound for the probability we do not have 5 consecutive blacks. So if we do it in blocks of length 5, what's the probability in each block of length 5 that we don't have 5 consecutive blacks? So in each block, we want to calculate the probability that we do not have 5 consecutive blacks. What would that be? 31 out of 32, or maybe 32 minus 1 over 32. I have 32 possibilities. Of those 32, I lose 1. And then how many times do I have this? I'm sorry, 20 times. And so this would give me a lower bound of 1 minus that. Yes? And so this is about 47%. That's not bad. With just a really simple calculation, because again, this could allow me to have 5 consecutive blacks cutting across 2 of the strips. This just means I don't have 5 consecutive blacks in the first, I don't have 5 consecutive blacks in the second. I could have something such as, red, red, black, 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 red, red, black. Something like that. Neither block would have 5 consecutive blacks, but I would have 5 consecutive blacks in the whole string. So this is going to give me an upper bound. It's going to allow certain sequences to be counted that should not be counted. So just by looking at groups of 5, we've already got 47% as a lower bound. That's not bad. Let's look at a block of length 10. So it's going to be 1 minus, and we're going to have something to the 10th power, right? So we're running out of space here. So let's do 10 blocks of 10. So how many sequences are there? 1024. So we have 2 to the 10 equals 1024 sequences. And we want to figure out how many to throw away. So it's going to be 1024 minus something over 1024. So how could you have 5 consecutive blacks? Okay, so one is black, 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 and then I don't give a damn for the last 5. So how many ways are there for that to happen? So how many sequences are there that start off black, 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 and then the next 5 can be anything?
1 plus 5 choose 2.
No, 1 plus 5 choose 2. I've got a sequence of length 10. I tell you the first 5 values have to be black, and the last 5 values can be anything. How many choices do I have for each of the last 5? I'm sorry? Anything. So how many choices for this problem? 32, right? Each one has how many choices? 2. So I've got 2 times 2 times 2 times 2 times 2 to the 5th. So it's 1024 minus 32. This counts all the ways we could start with 5 blacks. Well, we could start off with 1 red and then have 5 blacks and then have anything. So hopefully I can just quickly paste this. Yes. How many ways are there to do this now? To the 4th, which is, so I now lose another 16. And then of course, I could have red, red, and now I have to have 5 blacks. Right? And how many would that be? 8. And then, of course, I'm not going to keep writing it. I hope it's clear. Red, 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 red. And I think you know what comes next over here. So for the next one, how many would there be? 4, and then 2, and then the last one, 1.
What the cases where it's like black, red, and then a string of 5 blacks?
Ah. So have we forgotten those?
Yes.
So now we have, so good, so we forgot those. So now let's see, so we could do black, red, and all this. What else could we then do?
Red, black.
We could do,
So what if we have 6? What does that get lumped into different? What, black, red, black, and then 5 blacks.
so we could do black, red, and then from here, we could have 5 blacks. 1, 2, 3, 4, 5. And we would have 3 more left.
Yeah.
So we haven't covered this case. None of these cases align with each other. They're all distinct. Bless you.
Don't you just have to kind of flip it and take a case that the sequence of 5 blacks happens at the tail end? Like it's, and then we're like, well, we don't give, we can do like the asterisk on the left side, the left-hand side of the 5 blacks.
So the challenge is making sure you come up with a way to count where you don't double count and you don't miss anything.
Mhm.
So if we do 5 or more consecutive blacks, starting like this and shifting them down, that's fine. And so the question is, could we somehow change the counting here? So instead of red, red, could I maybe make this something red and then this? And then for the next one, could this become maybe something, something red? That's probably easier to just write them. 1, 2, 3, 4, 5, 1, 2. Could I write it like this? Would this be the way to count? We want to make sure we don't count anything twice. We want to make sure we cover everything. That's the hardest point with problems like this. It's really easy to miss cases. Now, to some extent, there's only one way to have two sets of 5 blacks. It's everything is black. So I'm not really worried too much about that. So if I have a string of blacks, there's got to be some place where it starts. And it either starts at the very beginning, in which case I don't have to worry what comes to the left because it started, or there has to be a red to the left. As soon as there's a red, do I have to worry about what comes next? Why not? So if I have a string of 5 blacks and then I have a red to the left, is it possible to have 5 blacks to the left of the red? No, there's not enough room. So I think something like this would actually work. So I think we have to modify it. And so we have black, 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 and then 1, 2, 3, 4, 5. Or we could then have red, and then 5 blacks, 1, 2, 3, 4, 5, and then, and now the next one is we could have anything here, and then a red, and then 1, 2, 3, 4, 5. What do you notice in all of these? How many are there in the first one? $32. How many are in the second? I'm sorry? 16. How many in the next one? 16. And in the next one, I can do any 2 things in the beginning, then a red, then 5 blacks. 1, 2, 3, 4, 5. How many here? 16. I could do 1, 2, 3 red. 1, 2, 3, 4, 5, 6, which would be another 16. I could do 1, 2, 3, 4 red. And then 1, 2, 3, 4, 5, which would be another 16.
Like,
Why? What's the one more 32?
I would say more 16s, like a star and then a red and then another star, and 5 blacks, then the 2.
So what you said is you want to do what? Star, and then a red, and then what? Then a star,
Yeah, then 5 blacks and 2 stars.
then 5 blacks. 1, 2, 3, 4, 5, and then 2 stars. Well, could this star be a black or a red? If it's black, we've counted it. Let's call this row 1, row 2, row 3, row 4, row 5, row 6. If this is black, I think that's just row 3. And if red, then it's in 4. So the question is, has this method now counted all of them? Is there any set of 5 blacks that we've missed? 5 or more blacks. Does this count 10 blacks? Yes, I get the 10 blacks from 1. If I have a string of 5 blacks, it has to start somewhere. And this looks like this starts all the different ones. And none of these can be the same because they all have a different place where they have a red. So does this count everything once and only once? I'm sorry?
Oh, this is just for 5.
Right. So I think 1 minus 1024 minus 32 minus 1, 2, 3, 4, 5 times 16 over 1024 to the 10. 1024 minus 32 minus 5 times 16 divided by 1024 to the 10. And this is about 68.6%. So as a quick estimate, this isn't bad. Just by, we haven't solved the recurrence, we haven't even written down that there's a recurrence. Just by looking at this and doing some quick estimates, with 5, we almost had that there was a greater than 50% chance of going bankrupt. By the time we hit 10, we have a really nice calculation that it's at least 68.6%. Technically, 68.5986%. So, but this is the power of being able to make quick, rough estimates. You often don't have to solve the problem exactly. You just want to get some rough sense. This is telling you have a greater than 2 out of 3 chance of going bankrupt. Okay. Anyways, I just think that this is a really nice problem. It shows you the ability of making some really good estimates. And it also shows how easy it is to write things down in such a way that you have double counted or forgotten to count things. And you have to really make sure that when you're going through, that you have a way of distinguishing. Could something in row 3 and row 5 be the same? Well, row 5 has an R in the 4th spot. Row 3 has a black in the 4th spot. They have to be different. So is it possible row 1 and row 6 could be the same? The 5th entry disagrees. It doesn't look like that because of how poorly this has been written, but in row 6, the 5th entry is a red, and here the 5th entry is a black. Does this remind you of anything you might have seen in an analysis class? Yeah, a little bit of Cantor's diagonalization, just making sure things are distinct. It's not quite the same, but by looking at this, I know none of these sequences are the same because 2 and 5 can never be the same because 5 has an R in the 4th spot and 2 has a black. Okay, so the next thing I want to do is I want to move to something I was talking to someone in this class about, rules for divisibility. They're just certain things you are expected to be able to do as a math major. If you've never seen them, you need to see them. Almost surely you've not seen at least one of these rules, but some of them you've seen. So if I give you an integer, I want you to tell me whether or not it's divisible by another integer. Some integers are easier to check than others. So what's the easiest integer check? If you want, you can be a smartass. 1. Right? We're not allowed to divide by 0. Right? Even math P, although we are in a physics building. So what's the rule to see if a number is divisible by 1? If it's an integer. Okay, rule of divisibility by 1 is so trivial, I'm not even going to write it down. What about 2? Yeah, 2 is if it ends with a, so I'll reorder this. Divisibility rules. 1, is it an integer? 2, so how do you want to phrase the rule for 2? Good. Ends in 0, 2, 4, 6, or 8. Actually, it's allowed to be 0. 0 is divisible by 2. Okay, what about 3?
Sum of digits.
Sum of digits. So divisible by 3 if and only if 3 divides sum of digits. How many of you have seen this one before? How many of you can prove this? Okay, what about 4?
If last 2 digits.
So if last 2 digits are divisible by 4, 5 ends in 5 and 0. 6, 2 and 3. Do rules for 2 and 3. 7. Sorry?
After 3 digits, the last 3 digits is the left part to subtract the right part.
Okay, but what if your number is more than 3 digits?
I mean, for example, if you have 1008,
Okay,
then you cut the last 3 digits and you say 1 minus 8, and it's -7.
okay, so it doesn't matter how many digits you have, you cut the last 3. Okay, so there is a complicated rule. So you are close, if not accurate. I think you're right. There might be a doubling. Complicated rule. 8.
Last 3 digits.
Last 3 digits.
What about
So if the last 3 digits are divisible by 8, so is the number.
how do we know what the last 3 digits are?
You just check and see if the last 3 digits are divisible by 8. So if I give you 2020, what's the last 3 digits of 2020?
0.
So it's the number 20. So is 20 a multiple of 8?
No.
No, so 2020 is not. If I gave you 2120, does 8 go into that? $120.
Yeah.
8 times 15. So because 8 goes into 120, 8 will go into 2120. 9, if sum of last 3 is a multiple of 9. 10 ends in 0. And then the last one we'll do is 11. I'm sorry?
That's 9 like that.
Yeah, I thought it was just the sum.
Oh, sorry. If sum of last, I'm sorry. So if sum of digits, if sum of, thank you. If sum of digits is a multiple, thank you. And 11, alternating sum. So we'll do these in a little bit more detail now. So I'm not going to bother with 2. I'm not going to bother with 5. I'm not going to bother with 10. Let's do 3. Here's the observation for 3. 10, you can write that as 3 times 3 plus 1. 100 is 99 plus 1 is 3 times 33 plus 1. 1,000 is 999 plus 1 is 3 times 333 plus 1. All right, does everyone see the pattern? So if I give you a number, say AD, what's total? AD minus 1 dot 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 A1, A0, this is AD times 10 to the D plus dot 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 plus A1 times 10 plus A0. And now for every power of 10, it's a multiple of 3 plus 1. So what I get is I get a multiple of 3 plus AD plus AD minus 1 plus A0. Right? Does everyone see? Because all of these numbers, these are all 1 mod 3. So since this is a multiple of 3, either both are multiples of 3 or neither. Okay, so this is the rule for 3. The rule for 9 is very similar. Instead of pulling out a 9, what do we do? For 9, you would just do 10 is 9 plus 1, 100 is 9 times 11 plus 1, 1,000 is 9 times 111 plus 1. And so it's a very similar argument to get multiples of 9. Okay, what about 4? So if I give you a number, AD minus 1 dot 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 A2, A1, A0, I can write this as my number AD minus 1, A2 times 100 plus A1, A0. Does everybody find that by A1, A0, I just mean the number that which has this as the digits that I'm not doing the multiplication? Everybody's comfortable with this? So what can you tell me about divisibility by 4 of this number? Yeah, it's divisible by 4. As 100 is 4 times 25, this is a multiple of 4. So again, either both or neither are multiples of 4. And then for 8, we use 1,000 is 8 times 125. And so the whole point is when I give you a complicated number, you can often chop off part of it and say, well, I understand how this part behaves, and now I just have to look at the other part. All right, so we've now done 1, 2, 3, 4, 5, 6, 8, 9, 10. So we have 11 and 7. All right, so let's do 11. So rule of 11. So how can we write 10? 11 minus 1. Beautiful. How can we write 100? Yes? Yeah, 99 plus 1. And what do you know about 99? 9 times 11. All right, what about 1,000? Sorry?
minus some and 1 minus.
So you could write it as 1001 minus 1, and 1001 is a multiple of 11. So how many times does 11 go into 1001?
91.
I'll just double check. It is 91. 91 is an interesting number. Does anybody know what interesting property 91 has? Is 91 prime?
7 times 30.
7 times 30. 91 is the smallest composite that looks prime that is not. Because if you do your simple test, is it divisible by 2, by 3, by 4, by 5, by 6? You know, it passes all of those tests. It doesn't pass these in a multiple of 7. So 91 is known as the smallest composite that looks prime. Okay. There's another way to look at 1,000. 1,000 is also 10 cubed, which is 11 minus 1 cubed, which is equal to negative 1 cubed mod 11. Is everybody comfortable with mod arithmetic? Everybody's comfortable with this? Abstract algebra is not a prereq for this class. Everybody's fine with this? Well, what is negative 1 cubed? That's just negative 1. So this is just negative 1 mod 11. What about 10,000? That'd be 10 to the 4th. Well, we know we can do it in multiple ways. 11 minus 1 to the 4th is negative 1 to the 4th mod 11, which is just 1 mod 11. So we can see that the 11s alternate. So if I give you a number, AD minus 1, screw that. Let's just do a specific number. If I give you, say, 8, 7, 3, 4, 5, 1, 7. So let's put the signs underneath. The 7 is going to have a negative sign, the 5 a negative sign, the 3 a negative sign, the 8 a negative sign. And the other ones will have a positive sign. So if I look at this mod 11, this is going to be 8 plus 3 plus 5 plus 7 with a negative sign. Let me do that in black. I put them in red. So this would be negative 8 plus 3 plus 5 plus 7. And then I would add to that the 7 plus 4 plus 1. All right. 8 plus 3 plus 5 plus 7, 10, 23. And then 7 plus 4 plus 1 is 12. So this would be negative 11. Yes. So is divisible by 11. And if we take 8, 7, 3, 4, 5, 1, 7, and we divide by 11, this is equal to 11 times 794047. So any questions on the rule of 11? What if I had accidentally started off with a plus sign rather than a minus sign? Doesn't matter. So instead of having negative 11, I would have positive 11. Not a big deal. So it doesn't really matter if you start off with a plus sign or a minus sign. Most people just start off with a plus sign, which whatever's the first one, just go from that. All right, so the rule for 11 is not that bad. However, what if I gave you a huge number and you did the rule by 11 and then you got a pretty large number afterwards? Iterate, lather, rinse, repeat, shampoo mathematics. So you keep applying this until you get smaller and smaller numbers. All right. So the last one is the rule for 7. I think this is what you were saying. So, searched online. I remember this every time I have to go into like an elementary school and do, rules of divisibility, and then I quickly forget about this. So the divisibility rule of 7 states that if a number is divisible by 7, then the difference between twice the unit digit of the given number and the remaining part of the given number should be a multiple of 7, or it should be equal to 0. This is not how I would phrase it. But I'm quoting, so do we really need, or it should be 0? I would say no. But maybe when you're talking with young kids, they might not consider 0 a multiple of 7. I would say it's 0 sevens. I'm quite happy with that as a. So here is a example. Let's take number 798. So the unit digit of 798 is 8. So we double that and we get 16. The remaining part is 79. We look at 79 minus 16, which is 63. 63 is a multiple of 7. So the original number should be a multiple of 7. And if we take 798 and we divide by 7, we get it's 114. So we do get 798 is 7 times 114. So this is the rule for divisibility by 7. You take the last digit, the ones digit, double it, subtract it from everything else. Right. Any thoughts as to why this works? Yes.
Is this an even only if condition or a one-sided application?
I believe it's if and only if.
Something a lot of work. It's not unscalable. You need to get down to a 3-digit number.
Well, so the question is, as you were to do this, what happens every time you apply this to the number?
Or you get.
Do we think we would lose more than, say, 1 or 2 digits? Do we think we could lose like 3 or 4 digits when we do this? Because we have to check and see, we chop off 1 digit and then we subtract double the units digit. So if my number is huge, if my number is 1,000 digits, I chop off 1 digit, it's now 99 digits. I now subtract off twice the ones digit. I'm probably going to still have around 999 digits. So look at the rule of 7 versus just, I don't know, trying to divide it by 7. Right? Which do you think might be better? I think it might be easier to just try dividing it by 7. If the number's not so bad.
Or because you could bash it in with the Math409Fa22 theorem.
In terms of how?
You write, I guess, 7 is 10, somehow it has to be 1 mod 7. And
So what you could do is you could do a weighted sum like we did with 11. And so if you look at the powers of 10, 10 is going to be 3 mod 7. 100 is going to be 2 mod 7. And you can keep going like that, and eventually it's going to repeat. And so that is another way to get formulas. There's more than one formula. So in operations research, I asked, what is my favorite college football team other than my alma mater, Yale, and my current school, Williams? And let's see if you can get it right this time. The Ohio State University, right? In math, we do not talk about the proof. We talk about a proof. Different proofs give you different results. And so if I'm trying to do divisibility, this is a great divisibility test, but you can also have something similar to the 11s where you have this alteration. What's nice with the 11s is it's just plus, minus, plus, minus, plus, minus, plus, minus. You just keep marching down like that. Not a problem at all. With the 7s, it's a little bit more involved, but eventually the powers of 10 have to repeat. Why? Why, when you look at powers of 10 mod 7, does it have to repeat? So 10, 10 squared, 10 cubed, 10 to the 4th, 10 to the 5th. Eventually, you're going to be repeating your remainders mod 7. Why? No, let's do something a little bit more basic than Fermat's little theorem.
well, they're always trying to mean remainders.
Right, so how many remainders are there in mod 7?
7 or 6.
So 7, because there's 7 remainders. So how many powers of 10 do I need to look at before I have a repeat? not 6. 8. What am I using? Pigeonhole principle. This is a pigeonhole problem, right? What do you have to do whenever you're doing a pigeonhole problem? What are the pigeons? What are the boxes, right? So the boxes here are the remainders mod 7. The pigeons are just the powers of 10. And eventually, so it's going to have to be periodic. And so once you look at 8 powers of 10, you have to have a repeat. You might get the repeat earlier, but you will definitely get the repeat by the time you hit 8. And so we could come up with a weighted combination. And so as a nice exercise, I'll have you try to come up with a weighted combination for that. All right, so let's see if we can figure out this rule for divisibility of 7. So, rule of 7. Out of curiosity, can people name the 7 dwarfs? All right. For the record, I of course can. Happy, dopey, dark, bashful, sleepy, sneezy, grumpy. And my problem is I often combine sleepy and sneezy into a super dwarf, and that is not an appropriate name for a dwarf. All right, so here's my number, AD minus 1, dot, 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 A1, A0. And what I do is I look at AD minus 1, dot, 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 A1 minus 2 times A0. Right? And let's try to think of what's going on. So my number here as AD minus 1, dot, 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 A1 times 10 plus A0. When I look at this mod 7, what is this equal mod 7?
Times 3.
So it's going to be 10 is just 3 mod 7. So this is going to be 3 times AD minus 1 A1 plus A0. Okay. Okay, now I want to compare this. This is my original number, and I haven't changed anything mod 7. And the test is we're supposed to look at chop off the ones digit, multiply by -2. Okay, well, look at this number. If multiply by 3 do not change if it is divisible by 7, right? So if I multiply this by 3, I would get 3 AD dot 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 A1 minus 6 A0. These are the same mod 7, right? What is this the same as mod 7? So what is this number the same as mod 7? It's the same as 3 AD A1 plus A naught. Because what I've just done is I've just added 7 A naught. Oh, wait a minute. This is the same mod 7 as our number. And this is the proof. So we noticed that if we look at our number, we can write 10 as 7 plus 3. When you multiply something by 7, that's going to be easily seen to be a multiple of 7. So we just have to look at 3 times those digits, that number, plus a naught. And then we notice over here, the nice thing is the -2. If I multiply by 3 becomes -6. And -6 mod 7 is the same as 1 mod 7. And so here's a proof. And so this gives you the rule of 7 divisibility. Yes.
Yeah, this is already right. So can we just look at AD -1 A1 minus the multiplicative inverse of M?
Yeah, I think that would be, I'll make that extra credit, is given some prime, what is the corresponding rule? And is there some rule where you just chop off the last digit? I think you should be able to find such a rule. I think the rule is not going to be that particularly useful when you have a huge number, because each time you're really only losing 1 digit. And so this is a great example of, we have a divisibility rule for 7, but it's so painful, I really wouldn't want to use it. A better one, I think, would be to note, 10 to the 0 is 1 mod 7. 10 to the 1 is 3 mod 7. 10 to the 2 would be what? It'd be 9 mod 7, which is the same as 2 mod 7. 10 cubed would just be 10 times 2, so that's 3 times 2, that's 6, so that'll be 6 mod 7. 10 to the 4th is, I would multiply 6 by 3, or I can just square the 2, that would be 4 mod 7. 10 to the 5 would be, I multiply 4 by 3 is 12, right? Which is 5 mod 7. And then 10 to the 6th would be 5 times 3 is 15, which is 1 mod 7. So if I give you a number, AD, AD -1, ... A8, A7, A6, A5, A4, A3, A2, A1, A0, I multiply the A0, that's the 1's digit, by 1. I multiply the A1 by 3. I multiply the A2 by 2. I multiply the next one by 6, then by 4, then by 5, and then by 1 again, and then 7 would be by 3. I think 8 would then be by 2, and so on. And so you would get the following weighted sum. You would get 1A0 plus 3A1 plus 2A2 plus 6A3 plus 4A4 plus 5A5 plus 1A6 plus 3A7 plus 2A8 plus ... So how many digits are we going to lose when we do this?
Approximately maybe log n.
So we're going to lose a tremendous number, because for every 7, was it 7 digits, 6 digits? 1, 2, 3. Every 6 digits collapses to a simple sum. What's the largest that sum could be? So I mean, if all these numbers that we were multiplying by was a 6, and we have 6 of them, it could be at most 36, right? So when you look at every set of 6, it's going to be at most a 36 that you're adding. So you go from something of size, maybe 10 to the 5th, 10 to the 6th, down to 36. And as you keep adding these, so I think you're probably right that it's a logarithmic drop in how much we have. And so you shouldn't have to do this that many times before your number comes crashing down. So I'll make this as an extra credit exercise, is, write this up. And again, I'm going to try to throw out a few of these things so that if you're not happy with your midterm score, you will have something to do. There'll be a second midterm coming up on Friday when I'll give it to you. We'll again have 2 weekends to do it. I will only count the highest midterm unless you tell me otherwise. Yes.
Here we have 10 mod 0 and 10 mod 3, 10 to the power 3 all adding up to 7, and then we have also 10 to the power 1, which is to the power 4, and then 10 to the power 2, 10 to the power 5. There's like a general rule that is this okay? Instead of
Well, yeah, it's 10:50 right now, so I'm happy to stay and chat with you, but I know some people have classes, so let me just stop recording right now.